Hey all, I figured whilst we were talking about factory Rover transfer case centre diffs and the Ashcroft ATB, that I'd go into them and pull them apart and show what's inside them. Apologise for the terrible audio on the last video. I'm only doing this with an iPhone that's a bit of a dodgy setup, and apparently when you clamp an iPhone with a vice grip to an old 4-foot level and then put that in your vice, which is attached to your bench, and then start dropping things on the bench, all the low frequency travels straight through it. Who knew? Anyway, this is the factory Land Rover LT230 centre diff, and as we talked about before, 2-piece hemisphere with all the gears inside. So if we take that off, we've got the side gear. There's 2 of these, one here and one underneath, and the 4 sun or pinion gears. This is a Ashcroft heavy duty cross shaft. It's 1 piece, as opposed to the Land Rover, which are 2 separate pieces and with material removed in the centre so they can overlap each other and be in the same plane. We sit back there. We've also got thrust washers. These are Tufnol, that's the material. These are available in various thicknesses, and you use the various thicknesses to shim it and get the correct engagement of the gears within the individual hemisphere. The bronze thrust washers here on the sun or pinion gears are one size. They do end up wearing out. Sometimes you'll pull apart the centre diff and there's none left, they're gone. So you get those with the Ashcroft rebuild kits, and you get a 1 thickness shim here, which is often not the correct thickness. So, you know, if you're going to do it properly, you do it as per the workshop manual, and you'll need various thicknesses to figure out which one you need. So if we put an output shaft in there, you'll see that that turns quite freely. The other side gear is rotating in the other direction, as it has to, because the centre diff is fixed. It can't rotate in this little jig. Very simple. Block of wood. Hole saw through the block of wood first. That's the first thing. Get your whatever size suits you. The appropriate size is just a little bit snug around the high-low hub splines. Once you've drilled that, cut the block down the middle so it's in 2 halves, and then you can insert that over it, and the amount that you've removed there allows it to be a tight fit, and it grabs on the splines. This is really good for being able to undo and do up the bolts. The manual just has you squeeze it here. You do have to squeeze it pretty hard in a vise for it to stop rotating. Now, you either do it without any protection on the jaws and mark up the crap out of all the hemisphere, which is not good, or you put something on the jaws to protect that, which is less grippy, they slip more, and you've got to do them up a lot tighter, and it's just something I'm not a fan of. This is really simple, very versatile. I just put it aside, can use it over and over and over, and we're not squeezing the crap out of the hemisphere to stop it rotating when you're trying to undo or torque up the hemisphere bolts. So as we said, that's free to rotate, very easy. Now, in operation, you've got the gearbox driving the transfer case. It's through the input gear in the transfer case. Then you've got the intermediate gear set, then you've got the output gears, either high or low range. Both those gears run on the centre diff, on the shaft, and one of those gears is engaged. Unless you're in neutral, either high or low is engaged, which means it's locked to this shaft and it turns the hemisphere. When that hemisphere is turning, the cross shafts have to turn. They're part of it. They can't, that's it, they're in there. So they're rotating with the hemisphere, which wants to turn the side gears. The way we get a differential in speed is through those side gears. So at the moment, because it's fixed, if you imagine I turn clockwise, the sun gears are turning the opposite way, which turn the bottom side gear or the other side gear in the opposite direction. Well, when we're driving, we don't have that. We don't have one prop shaft going one way and one prop shaft going the other. They're turning in the same direction. The reason there's a differential in speed is because this is rotating, and it allows what appears here as opposite rotation to happen as a differential in speed. So that's the basic factory centre diff. Like I said in the other video, so these are the forged and ground type gear. This is an earlier centre diff. I believe it was about 1998 where they changed to what's called sintered gear. That's the manufacturing process. They're fine. I don't think they fail on their own, just for sake of failing if everything else is okay. They're just not as good. It's slightly bigger, the gear. The hemisphere is the same externally and how it operates and everything, but I guess it was just a way to save a few cents on about 14 vehicles in the scheme of things, and that's what they do. But that's the setup is exactly the same right throughout, even when they went to the TDCI, and the hemisphere looks like a Rover diff. And if you've ever seen those, it's not this solid cylindrical hemisphere. It's cast. It's only got one cross shaft and it's only got two side gears. Much weaker. The hemisphere is more prone to flex, and the load sharing of torque and whatnot is only on 2 gears instead of 4. Terrible, but that's another thing. So that's our factory centre diff, and the way that diff lock works with that hemisphere back on. And I will say this, the hemispheres, and any hemisphere, whether it's a differential and an axle or a centre diff, ATB, they are machine matched. And what that means is you cannot just put that anywhere. There'll be, if you're pulling these apart and there are no indicators, put an indicator on it before you pull it apart. A simple centre punch there and there, one on each half is enough in line. These do have some markings on them. You can see there's a 5 and there's a corresponding 5 there. They have to be matched when they go back together. That's really crucial because they've been bolted together and then machined. So don't just put them back wherever suits, willy-nilly. They have to go back. These are case matched. There's a dowel on these. Diffs are case matched. There's a lot of matching of components prior to machining, so it's important to not just mix and match and go hell for leather in certain things. So that's our centre diff. For diff lock to work, so we've got the fixed output front to rear. You'll notice these are the locking splines or dog teeth, and at the moment they're out of alignment and then they're in alignment. So the locking collar sits down lower on the centre diff in normal operation when you're driving around unlocked on the road. So just, and when we engage diff lock, the collar slides up, and the collar is high enough that half of the collar is engaging the teeth here on the front output shaft, and the other half are engaging on the centre diff hemisphere. This is all bolted together. It's one piece. It's direct derived from the gear. This now cannot spin independently at all because the cross shafts are forced to rotate with the diff. Now the rear it can't slip because this one can't slip over the gears, so or turn the other way, or reduce. So that's how the diff lock works. It's a collar that slides down here and up here. If we take a look at the Ashcroft ATB, and I'll take this one out. We'll put our shaft in again, and just like in the other video, there's no way I'm turning that because of the ATB's design. That's fine. There's only 4 socket cap screws left in here. If I undo those, as I undo them, it may be visible, this join line here should get further apart, and that's because of the preload on the Belleville washers, which are 6 conical washers that are stacked back to back that end up acting like a spring when the case is bolted together. And that's part of the preload in the gears in the ATB. Just going around so the case doesn't go all cockeyed off as we undo it. That gap's opened up a lot more there. These are getting to the point where there's no more compression on the Bellevilles. And you'll see there's all the socket head cap screws and there's one missing. That's not missing, there's actually a dowel there. So we'll try and open this and hopefully everything stays behind. Yep. So, these are the pinion gears in the ATB, and you'll see there's 6 on top, up into the upper part of the hemisphere, and then the 6 lower ones, which are the same length, they're just down in pockets. This is our side gear here. Still splined exactly the same, but that's where the similarity ends. This is the helical gear cut on the side gear. Which matches the helical cut on the pinion gears. This is the Belleville retainer, which is splined to suit this holder here. It's got a shelf on it which will compress the Belleville washers. And there's 6 washers there. And hopefully you can see how there's a big gap, and then there's actually 2 touching, big gap, 2 touching, and a big gap. The washer is conical, and like I said, if you stack them back to back, they're touching in the middle, and when you compress them, it's like a spring. And that's the preload pushing the side gears out. So the side gears are already preloaded into the pinions. With the rotation, the pinions are forced into the pockets of the hemispheres, and that creates the friction that limits the differential in speed and outputs. Again, when the case is together, the diff lock works exactly the same way. Dowel pin hole, dowel pin there. So the output shaft slides inside, and again, it's the same profile. The locking collar comes up, locks the front output shaft to the hemisphere. Once that's locked together, that's all governed, and that's your output shafts turning equally, no matter what happens with your wheels. So you can still lose traction if you don't have cross axle diff locks. On the front and rear, you can spin one wheel and one front and one rear, and the transfer case will still turn, but you'll have no traction. That's independent. That's something else that's going on, not inside the transfer case. That's a bit of the machine work, the deeper pockets for the upper ones and the shallower pockets for the lower ones. all of this is this oil or whatever is a long life product, I assume, from the manufacturer. You know, they make it, they have to package it, then it gets sent to Ashcroft's. There's time involved in that. Who knows how long they sit on the shelves with Ashcroft, and then they get, you know, someone like me buys it and puts it on the shelf for 3.5 years before they get to installing it or whatever. So I will clean all this up and before I install it. I don't think it's necessary if you're getting one and putting it straight in, and I'm pretty sure that 99.9% of them won't be pulled apart, and there's a lot of merit to not pulling things apart. You can bite yourself in the butt, but since I've already had it apart, I will clean it all, and I will lubricate it with the synthetic oil that I'll run in the transfer case. These are not a limited slip diff. Do not run oils that are designed for limited slip diffs in ATB. It does them no good. These act on friction. We want the friction there. So even, you know, in the front or rear diff, if you're running an ATB, don't run an LSD oil. I just run the standard oil that I run in my LT230s, which is Castrol Syntrax 75W90, I think. Fully synthetic oil, it's a good oil. Again, run whatever you like, just make sure it's the right spec and good quality. So that's essentially what the inside of the ATB looks like, and a bit of what's going on in there. You can change the preload by changing the arrangement of the bell-wheels, and you can probably get different, you know, amounts of cone and stiffness in bell-wheels. I don't think that's something we need to play around with. I'm sure Ashcroft have done their research, their due diligence, and, you know, figured out what works for our application of running these in an LT230. I will be assembling this as it came apart, standard, and just, like I said, cleaning it up. The only thing I will do is I will probably replace the socket head cap screws, because they had some really good quality Loctite on them, and I was a bit concerned of even stripping them out when I was undoing them. So just to be sure, I'm going to get some exactly the same length and spec, good quality socket head cap screws, clean them all up, use some Loctite, if not 243, probably the high strength stuff, which I think's 271 or 272 on assembly, and like I said, just the lubrication from the standard LT230 gear oil. So that's a bit of a look at the difference internally. That might help someone. You might just be interested to know what they look like. Everything else functionality wise works great. You know, the fitment on a couple that I've had and been putting into transfer cases seems fine. You know, all the specs of the final specs of everything assembled comes together fine. So only time can tell. I haven't personally run one of these yet. A good mate of mine has. He's got a lot of driving experience, ex-racer, and long-time Land Rover owner. Lives semi-rural, so was doing a lot of dirt roads and asphalt roads, bitumen roads, and he and I are both quite fussy on, you know, making sure things aren't just height. He couldn't pick anything negative about it on the road, like it didn't give any weird characteristics or anything that was changing the dynamics of how the Land Rover drove. But on the dirt roads, an absolute improvement. He found just basically bloody brilliant, you know, just taking that little slop out, but also those slight little traction losses, and you know, it took those away, which made handling more predictable and more consistent. So it seemed to be a good thing. I'm confident in running one in mine, so maybe it's something you guys want to consider that might suit your needs. We'll just drop those back in there, and literally on the other side, this keeper is twice the height of these pretty much. There's one of these in my hand and there's one on the other side, so it's just mirrored. It's literally, there's nothing different in this other half, it's all mirrored. Here's the pinions again, they're all the same length. Now the important thing is, if you pull one of these apart, absolutely make sure the pinions, the 6 pinions that are in each half, stay with that half. If I turn this over, if we look at the direction of the cut, if I turn this over, it's still in the same direction. That's okay. If I swap it for one of these, I think we'll find if this will come out. So let's just look at that again. We're going down towards that way as we go down. If I take that out, if I take one of these out and turn that over, it's going the other way. That will be incorrect. And obviously if you mix and match them, it won't slide together. But if you've got all those 6 in this half and all these 6 in that half, which probably goes together, it's not going to function correctly. They're going in the wrong direction. It's going to be a problem. So make sure you don't mix and match the 6 pinion or the 12 pinion gears from top to bottom. The 6 in the top or front to rear, same thing. The 6 in the rear, stay in the rear. The 6 in the front, stay in the front. And you know, my basic school of thought is if you're pulling something apart and you're not familiar with it or understand the principles of it, which is pretty much me every day, really take note of what's happening. And you know, don't worry about thinking, oh, you know, like just do it. Take your time, put things aside. You can put them in separate bags or containers to separate them and label them. It saves a world of headache. Just simply, if nothing else, the time that it takes to pull things apart and get them right. And often we don't, once we know something's wrong, we don't necessarily know which way's right. So that's a guessing game. But worst case is, yeah, you can have things go bang when we do them wrong, and there's nothing worse than actually trying to do something, you know, and improve something or fix something, and you take your time and it doesn't work out because we've just been a little bit complacent. So that's my advice on that. And you know, we've all been caught out. We all make mistakes, but you know, avoiding them is a good thing. So that shows us a little bit of what the center diff looks like. Just to recap, I'll grab the factory center diff. So we can see them in the same shot. Side gear, both spline the same. Hemispheres obviously machined differently, but the output shafts do the same. Our 4 sun or pinion gears versus 12, but again, it's not just the number, it's the design and the functionality of how they work, which makes the difference. In saying that, a good, you know, if you've set your center diff up and you've paid attention to this, you know, the thicknesses of the shims and it's in good condition, and you don't need an ATB, they're fine. You know, I personally would not run later TDCI one with only the single pin and the 2 sun gears. I know that they failed in not so challenging conditions, but the general thing that I'm getting there is you don't need to change one of these if they're in good working order because you think it's going to break. What breaks them is incorrect use, generally speaking. So there you have it. Hope that helps. Cheers all.